Just like so many of the other Amazon Web Services, every time one comes along that really fits our need, like Cloud Search did so well, it allows us to focus on the product.
At Obama for America, we used pretty much all the services that were available. We used a lot of S3, used a lot of EC2, we used a lot of RDS, we used a lot of SQS. When we started thinking about how the technology was going to scale, we looked at a lot of the different providers out there, and we noticed that there was one that stood out amongst all the others, and that was AWS.
Businesses like Illumina are getting more and more involved with big data problems, and working with AWS lets us focus on what we're good at, which is doing sequencing, and at the same time have access to amazing computational resources for processing big data problems. AWS was clearly the best as we looked across the combination of security and scalability that we were going to need to build a powerful system to deliver to our customers.
For us to maintain a real-world data platform would just be prohibitively expensive. Instead, what we're able to do is use AWS to basically scale up our experiments and try out our new software on realistic configurations of hundreds or even thousands of computers. AWS gives us the resources to do our work at that scale and to solve real-world problems.
AWS has allowed us to be very efficient in our usage of servers. So instead of buying 1,000 servers to handle the amount of load that we're going to have for the year, we can actually scale up dynamically based on the current load that's going through our system.
When people are connected and are sharing data and insights, especially during times of crisis, it makes everyone's response effective and efficient, and make better use of already limited resources.
It's just really amazing to know that you have some of the world's best engineers and ops people working night and day at AWS on your behalf.
I don't think it would have been possible to reach the same level of performance and scalability without AWS.
Working with AWS has allowed us to run as fast as we can run.
It would have been impossible for us to scale base the way we have without AWS.
What will you run in the AWS cloud? Ladies and gentlemen, please welcome to stage Senior Vice President of Amazon Web Services, Andy Jassy.
Thank you. It is great to be here with you, and we really appreciate your taking a full day out of your time to learn more about AWS. I hope you find the day useful. We have been working on AWS for 10 years, actually, when we first came up with the idea. And we've had services in the market now for 7 years. And even though we've built quite a bit, we really think of this business and this platform that we've built as 7 years young. And that's because we have so much we're bringing to you just this year and in the coming years. So keep the requests coming, keep the feedback coming, and we're going to keep delivering quickly for you. But in the interim, we've built a pretty substantial technology infrastructure platform that's really fully featured. And it's got a number of compute services, a number of storage services, a number of database services, a content distribution network, a number of application services, a number of management tools and abstractions to make it easier to use our platform, and then a whole bunch of people services. We have professional services now, we have AWS Premium Developer Support, and then we have AWS Training and our newest people service, which we announced today with a press release, the new AWS Certification Program. I would say that outside of our operational performance and security over the 7 years that we've been doing this business, probably the thing we're collectively most proud of is the pace at which we've been able to innovate and iterate on behalf of our customers. And you can see in 2007, about a year after we got started, we released 9 significant services and features. In 2008, that number was 24. In 2009, it doubled to 48. In 2010, it was over 60. In 11, it was over 80. Last year, in 2012, we released nearly 160 significant features and services. And that pace is continuing to increase as time progresses. This year alone, in the first 4 months of 2013, we've delivered over 70 significant services and features for you guys, which is great news for customers because, as most of you know, our roadmap in AWS is largely prioritized based on what you tell us matters. And so that means you get more quickly, and it means you can move more of your workloads over and save time and money in the process. We have a very broad geographic footprint at this point, all over the world. And the way to think about the terminology in AWS is a region is a place somewhere in the world where we have physical infrastructure. So each region has multiple data centers, or what we call availability zones. And we have 9 regions at this point. We have 1 on the East Coast of the United States, 2 on the West Coast of the United States, 1 in Europe, 1 in Singapore, 1 in Tokyo, 1 in Sydney, Australia, 1 in South America, in Brazil. And then we have a government-only region in the US that we call GovCloud that has ITAR compliance, which effectively means that only US citizens can work on the workloads there. And that is really important for a number of public sector workloads that have that requirement. So we have 9 regions all over the world, 25 availability zones, and 39 points of presence or edge locations for our content distribution network, Amazon CloudFront. Just to give you a few points of scale for the platform, so our storage service, which is Amazon Simple Storage Service, Amazon S3, stores over 2 trillion objects. And it took us about 6 years to accumulate the first trillion objects, and only a year to accumulate the second trillion. And then just to give you an idea at the scope at which the service operates, we do over 1.1 million requests per second. It's a very large scope in these services. We have a service called Amazon Elastic MapReduce, which is really a Hadoop implementation on top of Amazon EC2, our compute service. And we've done 5.5 million clusters in the last couple of years alone. And then this is a really interesting data point. If you look at how much new server capacity that AWS is delivering every day, it would have handled all of Amazon globally back in 2003 when we were a $5.2 billion business with 7,800 employees. So every single day now, we're adding enough new servers to have handled all of Amazon globally when we were a $5 billion business with nearly 8,000 employees. That's a lot of data centers and a lot of servers that we're building every day. We have a very diverse and large customer base. We have hundreds of thousands of customers in over 190 countries. And they range from some of the most widely consumed internet properties like Pinterest and Spotify and Instagram and Airbnb and Dropbox to some of the largest enterprises in the world like Netflix and Shell and Samsung and Bristol-Myers Squibb and Hitachi and Toshiba, to the public sector where we have over 500 government agencies worldwide using AWS and over 2,000 academic institutions using AWS. So very diverse customer base. And when we started AWS, when we were conceiving of it and thinking about what to build, we had massive debate internally about where we should build the services, how much functionality we should build in, how many of the decisions we should make for our developers. And at the end of the day, what we decided was that we wanted to build very flexible, primitive building blocks. That's why when you look at the AWS logo and you always see those blocks, that connotes these building blocks that we're giving our developers to stitch together however they see fit. And we also very consciously decided that we were not going to be paternal. We weren't going to make decisions for our developers. And part of what that really enabled was enable our customers to stitch together our services however they saw fit to build whatever applications they could imagine or needed. And that's why you see literally every imaginable use case on top of AWS, from dev test to all kinds of internal and external website applications, to media distribution, to high performance computing and batch analytics, to archival and disaster recovery, to mission critical applications. Literally every imaginable application now is running on top of AWS. One of the questions that we get asked a lot, maybe a lot more so in the beginning, but it's always an important question to customers, is the platform secure enough? And that has got to be priority number one for every company. It's certainly priority number one for AWS. And so we use all the same strategies and tactics of technology companies the last 30 years. We have very strict access control to our data centers. We do a lot of work to make sure that none of the packets over the network are being intercepted in any fashion. We're very careful to wipe our hardware clean when customers give up that hardware and aren't using it anymore. But we've also added quite a few features over the last several years and continue to do so that allow customers to have even more security capabilities on top of the platform. And you see that with what we've done with identity and access management and very granular user management features. You see it with multi-factor authentication that we provide our customers the opportunity to use. You see it with offering customers dedicated instances if they somehow want to be the only ones running on a particular box. You see it with all kinds of encryption of our persistent stores and in our networking layer. A lot of our customers said, okay, as I inspect what you're doing on a security basis, I'm pretty impressed, but my company is going to insist that there are certain certifications and accreditations that you guys have in order to feel comfortable moving workloads to your platform. And that's why over the last several years, we have added a whole host of certifications that our customers asked us for, ranging from SOC to PCI compliance to ISO 27001 to being able to run HIPAA workloads in our cloud, to the Motion Picture Association of America, where we had a lot of media customers and film customers that wanted to be able to store comfortably their assets in our cloud. We got that certification. To a number of public sector certifications like FISMA Low, FISMA Moderate, ITAR, FIPS, very, very broad set of certifications that's made it easier for our customers to do what they want to do in our cloud. We have had for a long time, I'd say at Amazon in general, and in AWS in specific here, a very clear and consistent pricing philosophy. There are a number of companies, and most of the old guard technology companies fit in this class, whose pricing philosophy really is to charge as much as they can. And that is, by the way, that's a successful strategy, it's a high margin business strategy, and it's a totally reasonable business strategy. It just happens not to be ours. And you can see that in what we do. We work relentlessly to take cost out of our own cost structure and then pass them back to you, our customers, in the form of lower prices. And we've done that on 31 different occasions in the last several years in the absence of competitive pressure to do so. And what that really has done is it's given us this very interesting and useful virtuous circle, where as we have more AWS customers, it leads to more AWS usage. As we have more AWS usage, we have to buy more infrastructure. As we buy more infrastructure, it gives us economies of scale, which lowers our infrastructure costs, which allows us to reduce our prices, which spins that virtuous circle again. And as it turns out, you actually can inject energy into this flywheel in various spots. If you have a very vibrant ecosystem, if you have a broad global footprint, if you add a lot of features and services, it drives more customers and more usage and spins that wheel. And similarly, on the infrastructure side, if you're able to invent and innovate in your infrastructure, and we have a lot of IP that we're working on all the time, it allows us to lower our costs, which allows us to lower our prices, which again spins that wheel, which is very, very useful for our customers. We are so focused on reducing costs for customers that we invent features like AWS Trusted Advisor. So Trusted Advisor is a feature of our AWS support offering. And what we do is we have technology that automatically goes and checks for all kinds of different levers that would help you be more secure or more available or spend less on AWS. And you can see that one of the things we do is we check if you're running steady state workloads that are highly utilized, but you're running them on demand at a higher cost than it would be if you actually bought reserved instances, where you can save about half of the cost of running on demand. Or we'll look at when you have idle instances that you're not using. Or we'll look at when you have low utilization for your footprint. And what we'll do then is we will proactively send alerts and contact you and say, you should be spending less money on AWS. Now think about it. how many technology companies will call you up and say, I think you should spend less money with me? Not too many. But that's because AWS and Amazon as a whole has a culture where the most important thing, the thing that permeates everything we do, is that we start with customers and then everything evolves backwards from there. And I've been in Amazon for roughly 16 years at this point, and I've worked on every business that we've been in. And I can tell you that I have never met customers in any of those businesses that want to pay more. And so you should expect this from us. This is not a gimmick. This is not something we're doing for optics. This is not something we're trying to do to get attention in the press on a short-term basis. This is how we're built. This is our DNA, and you should continue to expect this from AWS. From the beginning, we always believed that having a vibrant, growing, successful ecosystem was very strategic to AWS. And we have partnered very closely with ISVs and with systems integrators from the get-go. And you can see it in how vibrant that ecosystem is. On the systems integrator side, we have literally thousands of systems integrators that help companies move their workloads and be more efficient on AWS. And they range from Capgemini and Cognizant and Infosys and Booz Allen. And on the ISV side, the technology partner side, we have a very large, vibrant ecosystem as well. And they range from SAP and Oracle and Esri and Acquia and MongoDB. And one of the things that has further helped this ISV ecosystem has been the AWS Marketplace, which we launched just about a year ago. And this is a marketplace that you can find on AWS where there are third-party solutions that you can buy, and you can even buy them in one click. They're very easy to deploy. And we have 25 product categories and almost 800 listings at this point, and that's growing very, very aggressively each month. And if you look just from January 1st of this year, you can see that our active customers are double from what they were before, and the usage per customer is growing by over 50% per customer. So a very useful vehicle for our ISV partners. Another piece of the ecosystem that makes a big difference for customers is our customer ecosystem. When there's a big technology shift that's happening, like what's moving to the cloud, if you have more fellow customers, either in your industry or that are geographically close to you, that are using that platform, it's more comfortable and it's easier to move. You also have more people to talk to about best practices. The forums at those companies' that cloud providers' websites are really vibrant and active. If you need to hire developers who, as part of their skill set, have AWS as a background, and if you look at how many job descriptions now have AWS skills as a requirement, it's pretty astounding. That's helpful. But what's also very important is that if you've got a large customer ecosystem, it drives the partner ecosystem I was just talking about to really want to build their solutions on top of that platform, and vice versa. They reinforce each other in a very important way. So why are so many customers moving to the cloud so fast? And there's a lot of noise about this point, and there's a lot of companies that have tried to kind of commandeer this type of messaging for their own purposes. But I thought I'd give you our perspective because we've been doing it the longest and we have a very large business as the leader. And I thought I would share with you at least what our customers are telling us. The first thing is, if you can trade capital expense for variable expense, for most businesses, that's a big business advantage. If you don't have to lay out all that capital up front for data centers and for servers before you know what you're working on is going to work, and instead get to consume it only as you need it, that gives you a lot more flexibility. So you get to trade capital expense for variable expense, and then number two, it turns out that we can provide you a lower variable expense than what most customers can do on their own. And that's because AWS has such large scale at this point that we're able to take those economies of scale and pass them back to you in the form of lower prices. And there are lots of customer examples we could cite. Foursquare with their analytics platform has saved 50% in operating costs. The Commonwealth Bank of Australia has saved tens of millions of dollars just in the first dozen applications they've deployed to AWS, and they're increasing that footprint on AWS. Spiegel TV in Germany was able to transcode 20,000 TV shows that they had wanted to do, by the way, for many years, but just hadn't found the resource to do it. They were able to do it in a couple days for less than it would have cost for the electricity in their own data center. And in fact, when you look at an independent study that was done by IDC, they found when they did the 5-year TCO analysis that it's 70% lower to run on AWS than it is to run on-prem. So you get to trade capital expense for variable expense. It's a lower variable expense than you can do on your own. And then you don't have to be guessing at how much capacity you're going to need. So for most people that are working on something new, that dotted green line represents, an estimate of what you think the capacity is going to be. And it's hard to estimate that. It's really hard to predict what's going to happen. And that solid white line is an example of an actual demand curve for that same project. And what you can see is on the left side of that graph, you're sitting on all this wasted capital, which is frustrating. And on the right side of the graph, you don't have enough capacity. So you either have to provide a bad customer experience, or what most people do is they run around like a chicken with their head cut off, and they do a short-term deal that has a long-term commitment, and it means that they overpay for it, and they have to sit on that peak even if they don't need it long-term. The cloud changes all of that. You don't have to guess anymore. You just consume resources as you need them. And if you need to scale up, you seamlessly scale up. If it turns out you hit a peak and you don't need to retain that capacity, you don't have to eat it. You get to give it back to us and stop paying for it. That's a very different model than the last 30 years. The fourth thing that customers tell us and why they're moving to the cloud, and I would say with enterprises over the last 18 months or so, this has become maybe the most compelling reason for them, is that they actually can move much faster and get more done for less. When we started AWS, we talked to a number of companies, and we do this same study every 3 months or so. We talk to developers at a lot of companies, and we say, how long does it take you to get a server if you want to put something in Integ, or you want to test something, or do something new? And the answers we got back ranged from 6 weeks to 25 weeks. That's maddening. If you're a developer, that's just maddening. And in fact, what a lot of development teams do at that point is they give up on doing anything new. Because why bother? It's going to take so long to get that server anyway. In the cloud, the world is very different. You can actually spin up hundreds, even thousands of servers in minutes. And it's all self-service. You can do it on your own without having to go through a million departments to make it happen. And anybody that does a lot of invention will tell you that arguably the two most important factors in doing invention is, number one, you have to be able to try a lot of experiments. And number two, if those experiments don't work, and if you're really pushing the envelope, a lot of your experiments should not work, not having to live with the collateral damage of failed experiments. In the cloud, if those experiments don't work, you either just give them back to us and stop paying for it, or you just take those same servers and use them for your next set of experiments. Very different model. And here are just a few examples of that. You can see News International, they were able to reduce their deployment time from 2 months to 3 days. Lionsgate went from weeks to hours in being able to deploy. You can see Bandpage can double their capacity in 20 seconds. Very, very different model. And in fact, again, when IDC did an independent study on this last year, they found that the agility amounted to 5x faster on AWS than what companies can do on-prem. The fifth thing that people tell us is it's a huge advantage not to have to manage the undifferentiated heavy lifting yourself. Running data centers is not impossible, but to do it at scale and as you're growing, it's hard. It's hard to do well. You have to go contract with a colo provider or build your own data center. You got to negotiate hardware. You have to install the hardware. You have to manage heterogeneous hardware. You have to migrate hardware. You have to set up a network. You have to negotiate with a bandwidth provider. You have to set all that up. You have to operate all of this. If there are any problems, you're on the hook to operate it. And so if you can take the scarce resource in your company, which most technology departments, most companies that do technology find that the scarce resource are software development engineers. If you can take those software development engineers and instead of having them focus on the infrastructure, which is important, but it hardly ever differentiates your business in any meaningful way. If you can have those software development engineers working on things that truly differentiate your business or mission, that's a big business advantage, and that's what you can do in the cloud. And the sixth benefit we hear frequently from our customers is that they can be global in minutes. This is really different from the way the world existed before. First of all, not only enterprises, but even startups today have global end users right from the get-go because of the internet and the way the world works. And in the old days, if you wanted to actually have your applications live in infrastructure all over the world, it was really hard to do. It was expensive. It was hard to find somebody you trusted. It was hard to deploy in those spots. With AWS, you can deploy in regions, 9 regions all over the world in minutes. And in fact, a good example of this recently is Qantas Airlines in Australia. They built a hotel booking business called Huru that actually books hotels along with all their flight plans, and they have multiple airlines they do this with. And they were able to deploy to a new region with 2 people in 2 days. That is a very, very different model. So to summarize, these are the benefits that we hear customers tell us really matter. You get to trade capital expense for variable expense. It's a lower variable expense than you can do on your own. You don't have to guess on what capacity you need. It's purely elastic. You actually get to move much more quickly, get more done for less and less time. You get to focus those scarce resources, which are your engineers, on things that truly differentiate your business. And you can have a global footprint with a better customer experience because of lower latency in minutes if you need to. Those are very compelling benefits. And to give you an idea of how that works in practice, I wanted to bring somebody up who is the lead engineer at a startup that went in just 1 year from founding to developing an app that processed 100 million emails per day to an acquisition all in the cloud. My guest is Sean Beausoleil.
Thank you, Andy, and thank you to AWS for having me up here today. As Andy said, I lead the engineering team for Mailbox, and I'm here today to tell you a little bit about how Mailbox came to be and how we leveraged AWS to make it into what it is today. So first, I want to give you a little bit of history. So a little over 2 years ago, a few of us sat down in the living room of our co-founder's house with the mission of helping people work better together. And the first iteration on that mission was Orchestra To-Do. And for those of you that don't know, Orchestra To-Do is a lightning-fast social collaboration management system. And we launched it a little over 1.5 years ago. And the reception was overwhelmingly positive. And our users loved it. But we came to realize that it had one fundamental issue. And that was that we couldn't get our users to stick with the product. And so when we started grappling with this issue and asking ourselves why, we found out that all the important things for us day to day and all the important things for our users and the people we interacted with was still stuck in email. And so we took a step back and we asked ourselves, could we take this place that held all this important information and could we reinvent this inbox where all these tasks already lived? And we asked ourselves, could a small team of designers and engineers tackle this daunting and previously untouchable problem? And so that launched us on this iterative journey of prototyping and building and scrapping and building, all of which eventually became Mailbox. And after months and months of hard work, we put together a video to show the world what we had been working on. And instead of trying to explain the product to you myself, I'd like to just show that video to you now.
Well, I feel like an old hobo. I'm sad, lonesome and blue. I was fair as a summer day. Now the summer days are through. You pass through places, and places pass through you, but you carry them with you on the soles of your travel shoes. morning so early just to tell you I got the wandering blues. I got the wandering blues, and I'm gonna quit these rambling ways one of these days soon. I sing the littlest birds sing the prettiest songs. The littlest birds sing the prettiest songs. The littlest birds sing the prettiest songs. The littlest birds sing the prettiest songs.
So we launched this video in December, and we were hoping to get about 100,000 views as we ramped toward product launch. But what ended up happening is we got that in about 4 hours. And from the early users we had on our product and from the press, the reception was just overwhelmingly positive. And it started to feel like we had the scent of product market fit. And we knew that what they were reacting to was this amazing client engineering, these fluid animations, this beautiful UI, this fresh take on the inbox. But we also knew that in order to power this experience, we had to build a massively scaled backend that would iterate on this 25-year-old IMAP protocol and build it in a way that was better designed for a world on the go. And so to help a bit understand what that meant for us, let me break down Mailbox for you a little bit. So the cloud is an essential part of why Mailbox is so fast and seamless. Mailbox checks the mail on your behalf, reformats the messages, and efficiently delivers them down to your client. And for every email address that's added to our system, we have instantaneous load because we need to sync your data as fast as possible. And then we have continuous load throughout the day because whether you're in our product or not, you're going to be interacting with your email. And we need to stay in sync with all of those data events. And you add to that this is email. It's business critical. It can't go down, it can't be slow, it has to always be fast and always be available. And that all adds up to quite a bit of infrastructure and a really hard problem for a small team. So we knew that in order to scale up to meet this demand that we were seeing, that we had to have a production level backend system from the very first day. And so we turned to AWS to help us do that. And we knew that we wanted to find as many limits and bottlenecks in our system before we launched and long before they could ever negatively affect any of our users. And so what we decided to do was spin up an exact mirrored clone of our backend, sitting next to our normal backend infrastructure. And this included our SSD databases, our application servers, the whole thing. And instead of slamming our own email accounts with hundreds of thousands to millions of data events to load test our own system, we built an IMAP server that we were able to sit right next to it. And because this was on demand, it was really quite powerful for us. It was both cost effective and very effective for our team to be able to we found assumptions that were just incorrect at larger scale. We found bottlenecks that we just didn't anticipate and layers that we needed to kind of re-architect and rebuild before we launched. And it also allowed us to find the limits of the various parts of our system so that we could predict our growth as users were added. But we knew that no matter what we did, we weren't going to be able to build it perfectly from the very first day. And so we knew that also that was what was most important for us was that the users that were already in the system had the best experience possible. So we decided to build this reservation system because we didn't want any new load being added to the system to negatively affect anyone else who was already in. And the reason this slide says rapid product development is because the story of our reservation system is really a microcosm of our team, how our team operates. We identify a problem, we prototype, we iterate, and we execute in a very short amount of time. And that was very true for our reservation system. Just a few weeks before launch, when we decided to implement this, we had 2 engineers build the whole thing end to end in just under a week. And we turned to AWS to help us power that. We knew we needed a database that was reliable, that would handle all of the scale and demand of all of these requests that would be coming in, and one that we didn't really want to manage because we needed to focus on scaling our core product, and we didn't expect this reservation system to be around forever. And RDS was an amazing asset for us in being able to execute this system quickly. But no matter what we did to prepare for scale with spinning up this mirrored system and throttling the load of new users added, there was nothing that really could have truly prepared us for what it was like to launch this. The scale and demand of the product when it got out into the wild was just incredible. And while this graph, if you took out the y-axis, could really represent the amount of sleep we've gotten in the past few months, it really does tell a compelling story of just some amazing feats of engineering, some just-in-time engineering to stay ahead of these issues as we scaled up to handle 100 million emails a day. And that's really been the story for us since launch. A lot of re-architecture on the fly, identifying pieces of the system that need to be swapped out or improved or completely eliminated. And AWS has been a great partner in that. The flexibility and elasticity that they offer has really allowed us to move quickly and scale this thing out. And I think if I gave you a picture of our backend a week before we launched and today, the picture would be dramatically different. And I'm sure, as many of you are aware, when you launch a production level system, you can't really know what production's like until you're actually in production. And in a lot of ways, it's like jumping off a cliff and hoping everything's all right as you're on your way down. And we've been really fortunate to be able to take advantage of being able to identify queuing layer bottlenecks, identifying parts of the system that need to be improved or optimized. And we're really enjoying doing that right now. We've built a lot of detailed monitoring on top of our backend that you can see here. And it allows us to identify problems in the moment and to be able to predict problems and improvements as they're coming. And one example of this is just last week, we found one of our application servers that could be swapped out that was 16% more expensive, but 72% more efficient for our use case. And we're just really enjoying going through this process and figuring out how to make our service custom fit to our data and our usage patterns. And we feel really fortunate to have AWS as a partner in doing so, and to be able to take advantage of all the hard work they're doing and the new services that continue to keep coming out, so that we can focus on our product and doing what we love to do and helping people work better together. So if you haven't yet, please download Mailbox, give it a shot. We'd love to hear what you think, and thank you for having me here today.
That is very cool. So I thought I would talk a little bit about how the enterprise is adopting AWS. And this is happening at a very rapid pace at this point. And I thought I would go back to where I left off right before Sean came on and remind you of the benefits that we're hearing over and over again from customers and why they're moving to the cloud. And what's interesting is that there are a lot of old guard technology companies that are telling enterprises, you can get all these benefits, but what you need to do is do it in the private cloud. You get to do it on premises. You don't have to worry about security. It may cost tens of millions of dollars, maybe over $100 million, but you'll have it on your premises. However, when you actually carefully look at the benefits of why people are moving to the cloud, you realize that the private cloud has none of them. And in fact, for companies that are actually spending a lot of money and time on the private cloud, it's hard to actually get even kind of core capabilities. So Forrester did an analysis over the last several months of companies that have been working on private clouds, and you can see that even basic capabilities like self-service provisioning and cost chargeback and resource tracking, hard to actually get done. And so you ask yourself, well, why then are so many old guard technology companies telling enterprises that what they got to do is go build a new private cloud? And I think the reason is that the model that AWS is pursuing and that the cloud is moving to is very disruptive to these old guard technology companies. They have built high margin businesses on a set of products that aren't quite as compelling if the world moves this direction. And so it's very important as you're thinking about as an enterprise what you want to do to really cut through all the noise and evaluate what value you can actually get from why so many people are moving to the cloud. Now, when we talk to customers about this, sometimes they get really nervous because they say, well, wait a second, are you saying that I have to choose between two choices, either all in to AWS or all in on a private cloud? And the answer is no. We know that there are a lot of enterprises that have data center and technology assets that they're not ready to retire yet. And they actually want to get value out of those before they transition off of them. And they also want to take advantage of AWS in the cloud. And so we're building tools along with our ecosystem to make that simple for enterprises to do. And that's why you see things like us integrating Active Directory for customers with our user and identity management services, why we're building all kinds of network configurations to make it simple to move directly from your data center to AWS and back again. It's why we're working on encryption services. It's why we're actually working on appliances that allow you to store data in your enterprise but asynchronously back it up to the cloud. All of those types of tools are all happening now, and you'll see more of them moving forward. And you'll also see us work very closely with our ecosystem of partners to make it simpler for enterprises to get some of these things done. So we've been working closely with BMC and CA as a couple examples of many to allow enterprises to have a single pane of glass to be able to manage their deployments both on-prem and in AWS in one pane of glass. You see a partner I'd like to call out today, Okta, and congratulate them as they launched today their identity solution that integrates Active Directory with AWS's identity and access management. You see those coming out every week, and I'd expect to continue to see those. So how are enterprises using AWS? And sometimes people assume that there's one strategy, and that's it. But what we see, not surprisingly, because there's such diversity in businesses and companies and cultures and geographic differences, that there are many strategies that enterprises are using to deploy on AWS. And I thought I would give you 6 of them. The first, which is probably pretty obvious, it's often how a lot of big new technology shifts happen in the enterprise, is that they're moving dev and test to AWS. And that's been happening for a long time. And Lionsgate has moved their SAP dev and test environment. Tokyo Stock Exchange is a big Oracle user. They've moved their dev and test environment to AWS. Galata Chemicals has saved 70% on their operating costs for dev and test by moving it to AWS. That's been happening for a while, and it continues to happen at a very fast pace. The second strategy is that enterprises are building altogether new applications on top of AWS. These are applications that don't have any legacy. They don't have to be migrated. These are often projects that people at the company have wanted to do for months and years and never really had the resource or the support or the wherewithal to get it done. And you see this happening quite a bit as well. You know, the Washington Post has built a Facebook application that actually has more viewership than their physical print newspaper. You see PBS building all kinds of streaming apps on top of AWS. Outback Steakhouse has done a lot of their marketing websites on top of AWS. It's kind of a no-brainer. It's faster to build, it's less expensive to run, it's easier to manage, and you can leverage our capabilities that allow you to have high availability across multiple availability zones. The third strategy we see for enterprises using AWS is that they take on-prem apps and then they use the cloud to make them better. And you can imagine there are so many apps today where the amount of data they're storing and trying to use is very large, where they'll run the app on-prem and then they'll do the analytics in the cloud. You know, either using Amazon Elastic MapReduce, which is our Hadoop on top of EC2, or Amazon Redshift, which is our data warehouse service. Or you can imagine backing up all your resources to Amazon S3. You're seeing these use cases all the time now. And you know, these are a few of the examples. NASDAQ, they run most of their trading applications still on-prem, but they move out to AWS frequently to do analytics on a bunch of that data. Or McGraw-Hill, who's a big Oracle database user, they now, with a simple few flicks or clicks on a UI, can point their Oracle database with RMAN to S3 to store that data. Or Jollibee, which is a large restaurant chain in the Philippines. They have 2,500 stores. It's a $2 billion business. They're running data synchronization and backup with AWS's storage gateway. So a lot of people taking on-prem apps and using the cloud to make them better and enhance the performance. The fourth strategy is people taking cloud apps, so apps that are largely built in the cloud now, and then finding a way to integrate them and make them better on-prem. And so an example of this is Samsung. They have their Smart Hub interactive TV application on top of AWS. But when people buy content, they want to be able to integrate those transactions with their transaction processing system on-prem. And so they've built an app that largely runs in the cloud, and when it does payment transactions, it integrates with their on-prem transaction service. A fifth strategy is companies migrating large portions of their workloads to AWS and to the cloud. And we're seeing more and more of this. This takes more planning and thought, and it either takes a lot of thought internally or often with some of our systems integrator partners. But you're seeing more of it. News International, as an example, has moved a third of its servers to AWS at this point, and they've saved about £1.5 million, which they expect to triple in the coming years. Unilever now has over 1,000 websites that they are running on AWS, and 500 of them they've actually migrated from on-prem to AWS. And Bristol Myers Squibb, this is a really interesting example. They've migrated their clinical trial simulations to AWS. And simulations that on-prem used to take them 60 hours now take 72 minutes. That's a huge difference. And so it not only lets you move faster, but also it means you don't have to use as many human subjects. And when you're doing clinical trials, many of which are for children, having to use less children and draw blood from fewer children and get the clinical work done quicker so you can actually get to the substantive stage of making the drug is a big deal. And then the sixth strategy is what I would call all-in. And this is a strategy that some enterprises have undergone, others are in the process of doing, but it really involves moving everything, and I'll call it about an 18 to 24 month period. And the most visible of which is Netflix, which really runs virtually everything on top of AWS. 95% of their workloads are on top of AWS, with the remaining going to be there by the end of this calendar year. And this is a more courageous and more bold move. However, with that boldness, you get to enjoy the benefits and the advantages faster. You get to save more money because you've gotten to the cloud faster. You get to move faster. You get to actually spend your scarce resource on things that really differentiate your business. In Netflix's case, is providing a killer movie experience. You get to do that faster. You get experienced in the cloud faster. There's a lot of benefits if you can actually organize to take advantage of a shift that you know is happening. You know, there's an expression that people use, which is, it's really hard to fight gravity. And if you know something is happening, it's really your best strategy to embrace it and figure out how to make it happen as fast as possible while still safe for your environment and culture. If you have the courage to do it faster, you get to enjoy more of the benefits faster. So I thought what I would do is bring up our esteemed senior technology evangelists to give you some live examples of how enterprises are actually utilizing all of these strategies to move to AWS. This is a man, there are very few people who come up in front of you and wear pink pants and get away with it. But this man can do it. He's a great speaker as well. Please bring up Simone Brunozzi.
Thank you very much. Buongiorno, San Francisco. Good morning. I'm so happy to be here today. And I want to apologize. You were expecting a beautiful French lady on stage. Instead, you get this guy by the name Simone. They say that a demo is worth 1,000 words. And what I'm going to show you today is a demo that relates to enterprise and cloud. So there is this habit that we use to think of enterprise and cloud as two separate worlds. We have usually the internet in between. They are on the side of our slides. And even if there are great ways to connect them through a VPN tunnel through the internet, or even by using the AWS Direct Connect, which is a great option, still, we keep considering those two things as separate ones. Instead, what I want to give you today is a demo that hopefully will change your perception about this. And I decided to record the video instead of showing you a live demo. And the reason being, there are many parts, and I wanted to take the relevant ones for the interest of time. So I will show you some segments of a longer demo, and of course, they are recorded. I will cover 3 things today. First, I want to talk about how you can authenticate on AWS by using your Active Directory credentials and systems. Number 2, I want to tell you how to use the AWS Storage Gateway to integrate on-premises and cloud together, especially for backup and disaster recovery purposes. And third, I want to tell you how you can easily move workloads or disk images or snapshots to the cloud, and then also move it around to other regions in other parts of the world. So let's start with number 1, authentication. So this is the Identity and Access Management dashboard. This is a service that lets you manage users, groups, and roles. And this is the EC2 admin role. This one lets your users do anything on EC2, but not on other services. Let's switch to Active Directory now. This is a list of our users. We want to give them, for example, EC2 admin rights. How can we programmatically do this? We could use the Amazon APIs to write code for that, or we could use our partner Okta. This is the Okta dashboard. You have to enter your AWS credentials, like in this case, just once, just the first time. And then if you go on the People tab, you can see that this is the list of people in our Active Directory environment. If you go into groups, you can see, very important, one of those groups named EC2 admins. If you click on that group, there is a way, an easy way, through Okta to enable this group to have specific AWS permissions through IAM, in this case, EC2 admin rights, which means that now we can even forget about this tool, go back to Active Directory. This is our list of users. That's Simone Brunozzi. We want to give him EC2 admin rights, so we open the group, we add Simone to this group, very easy, find it on the Active Directory, click Apply, and after a few minutes, changes will be applied to the systems. I can just do a Windows login with this user. I can open a browser with the AWS Management Console set as our default page, and automatically I'm logged into AWS with the right credentials, in this case, EC2 admin rights. So it's super straightforward, seamless, and there's no need to do extra integration with it. Let me show you now how to use this storage gateway to do backup and disaster recovery. So as you know, the storage gateway is a service that connects on-premises software appliance with cloud storage. And in our case, what we're doing is we are taking snapshots of one of our volumes into the cloud, into Amazon Web Services. In this case, and with Storage Gateway, those volumes are stored inside Amazon S3, which, of course, as you know, is a highly durable storage service. But then let me show you how our setup looks like. This is the AWS Storage Gateway console. This is the volume I was telling you about. It's a 10 terabyte volume. We are in the on-prem gateway right now, so the machine we have on premises. And if we look at the snapshot schedules, you can see that snapshots are taken every hour for this volume. And of course, those are incremental snapshots. So let's imagine that something bad happens to our infrastructure, to our physical infrastructure. Our servers go offline for any reason. And now we are facing this dilemma. What should we do? How can we use the storage gateway to restore, to do a disaster recovery for this situation here? So we will take this snapshot out of S3 and instantiate an EBS volume out of it. And after this is done, we will just launch an EC2 machine, and this machine will host the applications that we were using on premises just before the disaster happened. So let me show you how this works. This is, again, the storage gateway interface. Let's take a look at the latest snapshot. We will need to take a note of the snapshot ID, because we will need it in just a few seconds. Then we go to the EC2 gateway, and first we need to create this volume out of that snapshot. So we specify some parameters, such as the cache storage or the upload buffer size. We can set up alarms if we want to. We set the capacity to 10 terabytes. We give this volume a name, and very important, we pass the snapshot ID that we want to use. When everything is ready, we can launch it, and after several minutes, depending on the size of the volume will be available. There's one more thing we need to do. We need to take the iSCSI target info for this volume, log in into that machine, in this case it's a Windows machine, open the iSCSI initiator, enter that iSCSI target info on that form, apply, and then if we go to disk management, we can see that in just a few seconds, that volume will be available and online, ready to be used and ready to host our applications. So at this point, we could even go further and map this application running in the cloud to our on-premises environment. So if it was an internal app, for example, our colleagues in our company could start using it again as if nothing happened. Third part is about migration. And in this case, I will show you the vSphere client by VMware. VMware is one of our partners, and they created a function, a feature in the vSphere client that lets you export your volumes into AWS. And this is what we're going to do. We imagine we have an on-premises environment. We first export those disk images into one AWS region. And then we want to move those AMIs, Amazon Machine Images, from that region to another region. Let me quickly show you this as well. This is a vSphere client. We want to export this specific image, so we go to File, Export. We specify the file name, some parameters. We run a simple script, and after we do this, the disk image will be transferred to AWS, and it will become an AMI, an Amazon Machine Image. Then we can select this AMI, which is currently in North Virginia or US East 1, and we can copy this AMI to another region. In this case, we will pick Singapore. I used to be based in Singapore before moving to the US, and I'm sure that my colleagues are watching the live stream, so hello guys. And in Singapore, I'm starting the transfer right now, and now that the transfer has been initiated, I can actually go to the dashboard for the Singapore region, up to the right, and I can see that the AMI is now being created. Of course, it would take a while depending on the size of the AMI and my connection speed, but then this machine will eventually be available there, and then I can do anything with it. So in conclusions, those are just some examples of tools that are available today. So all that you saw here in those videos, you can do it by yourself from your office, from your home. Those tools are available today. There are many others that, of course, we didn't have time to cover. And I think that now your perception of how the enterprise world can talk with the cloud world might have changed a little bit. I want to thank you very much for your attention, and have a great day. Goodbye.
Thanks, Simone. So what have we been working on over the last chunk of time? It's a lot, I can tell you, as we talked about earlier. On the compute side, we have a number of compute services, but a number of features, a very large number and growing features for our Elastic Compute Cloud, or EC2. And so recently, really through feedback from our customers, we've added a number of new instance families to EC2, and we have a much larger number of instance families than really anybody else has available. And we added a high I/O instance family. We added a high storage instance family. We added a high memory cluster instance family. We refreshed our existing standard family, which we'll continue to do as we go through time and as more technology continues to be made available. So a lot of iterations and new family instances and new capabilities for our customers in EC2 as we build instance types that are optimized for various workloads. We have an auto-scaling capability in EC2 that a lot of our customers employ, which effectively allows you to set up automatic triggers for when you'd want to grow your number of instances automatically without having to take any action, or when you actually want to descale and shed some of your instances. We have a load balancing capability, which is called Elastic Load Balancing, that many of our customers use. And then we have a service I talked about earlier, which is Amazon Elastic MapReduce, which is a Hadoop implementation on top of EC2, which a lot of companies are using to do big data analytics. We also have a number of networking services that really were the result of our customers asking for these capabilities so that they could run more of their workloads on AWS. And so we have something we launched several years ago called Amazon Virtual Private Cloud, or Amazon VPC. And the way to think about that is it's like you're cordoning off a part of the AWS network, and then you're able to provision resources into that part of the network. And it can only be addressed through IP addresses that you bring to bear, or for certain subnets in your VPC, you can make them addressable via the internet. And you can connect via your own data center via VPN capability. And over the last several months, as more and more of our customers have been using VPC, they've asked us to make all of our services accessible via VPC, which we've done. We also have a capability that we call AWS Direct Connect, so that enterprises can have a high-speed private network connection from their data center directly into AWS. And then we have a DNS service called Amazon Route 53 that allows you to use AWS for DNS, so you don't have to go to multiple providers, and it integrates really well with AWS and with Elastic Load Balancing. We have a series of storage services, some of which you've heard about today. Amazon Simple Storage Service, S3, is our very large object store, very durable. We have something for persistent storage with EC2 called Elastic Block Store, or EBS. We have a storage gateway that we launched last year, which effectively is an appliance on-prem that allows you to then asynchronously store your data to the AWS cloud. And then we're able to store it in such a fashion that if you need to spin up volumes, EBS volumes, to then run compute on with EC2, you can do that very easily in the way we store it in our cloud. And then our newest storage service, which we launched late last summer, called Amazon Glacier, which is our backup and archival storage service. And this service allows you to do backup and archival for 1 cent per gigabyte per month, which is very inexpensive and cost effective. And it's built for 11 nines of durability. It's designed for that, like S3 is. And what's really interesting is not only is this service the fastest growing service by a lot in the history of AWS in terms of the number of customers using it, but also a lot of our customers have found uses of data and the ability to store data that in the past they felt financially they had to basically delete. And now, because of how inexpensive and how durable Glacier is, they can store data and keep it for a longer period of time, which in some of these businesses is very useful. We have a number of application services. So we have a content distribution network called Amazon CloudFront. We have a search service called Amazon Cloud Search. We have an email service called Simple Email Service, or SES. We have a queue service called Simple Queue Service, or SQS. We have a notification service called Simple Notification Service, or SNS. And we have a workflow service called Simple Workflow Service. Very broad array of application services that we continue to roll out to make it simpler and simpler for customers to be able to move their workloads the way they want to our platform. The latest application service that we launched is called Amazon Elastic Transcoder. And it's a transcoding service, and a lot of our customers who do media and video in particular, as video is exploding in terms of usage, had to roll their own transcoding capability in the past, which they can do, but is time-consuming and often difficult. And it was a little bit more expensive than they wished. And it turns out a lot of times these can be spiky workloads. So a number of our customers asked us if we would provide a solution here, and that's what we did with Elastic Transcoder. It's a fully automated video transcoding service. It's easy to use with our management GUI and our APIs, and it handles very large volumes, and customers are very excited about this in the media space. We have built, over the last number of years, a number of deployment and administration and management capabilities to make it easier to use AWS. So we launched a monitoring service called CloudWatch that we continue to roll out features and capabilities for. The vast majority of our customers use. We have granular level user management. So think of it as having a parent account and then having users underneath that parent account who have separate credentials so that you can have different security for them and different permissions to different resources for them. We have a web GUI that's our management console to manage your deployment on top of us more easily. And then we have a number of deployment services that people are excited about, and it just depends on how much control and what you want to do for which one of these you use. So we have something called AWS CloudFormation, which you should think of as like recipes or templates for workloads that you want to deploy in a repeatable fashion. Then we have something called Amazon Elastic Beanstalk, which is really a container that allows you to upload a file to us, and then the service automatically provisions the EC2 instances, the load balancing, the auto scaling, the monitoring, and it is a really easy way for you to deploy your application on top of AWS. And over the last year, we have metronomically been expanding the number of languages that Elastic Beanstalk supports. So now it supports Java and PHP and Python and .NET and Ruby and Node, which is the newest, which is off to a blazing start. Our newest service in this area is called AWS OpsWorks, which, if you want more control than Elastic Beanstalk provides, and you want more automation than CloudFormation offers, OpsWorks is the service that people are using. It's really a DevOps platform, and people that want that level of control but want a number of automation capabilities are excited about OpsWorks, and it's free. We also have built something called AWS Data Pipeline, and this is a service that heavy users of AWS are pretty excited about. And that's because if you're using various AWS services with all kinds of workloads, it used to be time-consuming and challenging to figure out how to move that data between AWS services and how to build automated ways to actually process jobs once you've taken certain steps. And so AWS Data Pipeline effectively allows you to build in a very easy way a custom workflow where you can move data between different services of AWS. You can schedule that to happen. It can be on the hour, it can be at certain days, it can be when certain actions happen. And then you can also build triggers of additional activities, processing jobs you want to happen at different steps along the way. We also heard frequently from several customers, particularly enterprises, either who had very valuable assets that they were storing in AWS, or where they had regulatory commitments in their vertical industry that had very tight security around and restrictions around compliance and protecting the keys. And so what we heard from those customers was, boy, I wish I could move this workload over, but these workloads need to leverage hardware security modules that I need to store in my data center, so the performance, the latency performance, isn't good enough to move those workloads over. So we just launched a few weeks ago HSM as a service that effectively allows customers to store their most sensitive crypto keys in a hardware security module. We monitor and manage that service, but you, our customers, control the keys. It makes those applications performant now to run in AWS, and it lets our customers comply with the strictest regulatory rules that they have in their particular industry. We also have a number of database services. We have a relational database service called Amazon RDS that comes in a few flavors. We have MySQL, we have Oracle, we have SQL Server. We have a NoSQL database called Amazon DynamoDB, which is a very fast, very high throughput, non-relational database. It has single-digit millisecond latency for reads and writes. And in this generation of applications that use so much more data and really want to use that data near real time, it's becoming the database of choice for those types of applications. We have a caching service called AWS Elasticache. And then one of the things that we started getting asked about maybe 18 months ago, maybe 2 years ago, was that we had a number of large customers who said, I need a data warehouse, but I really don't like my current solution. It is really expensive, and It's really complicated and hard to manage. And if you guys, AWS, would think about doing something in the data warehousing space, we would be much obliged. And then we vetted that as well with some of our fast-growing startup customers, and a lot of them said, well, given the price structure of these data warehouse solutions today, we can't even really think about a data warehouse option, even though we really want to use one, and we have a ton of data that we're collecting every day. And so this type of feedback from customers prompted us to build Amazon Redshift, which is our data warehousing solution that we just launched a couple months ago. It's the fastest growing service in the history of AWS at this current evolution. And it allows you to scale from hundreds of gigabytes to a petabyte or more. You can use all your existing SQL-based tools, all the traditional BI tools it integrates well with. Like all the AWS services, you pay as you go. We handle all that scaling and management of a data warehouse for you, so it's not complicated and onerous to manage. And it's 1/10 of the cost of the traditional data warehousing solutions. It's less than $1,000 per terabyte per year. That is a game changer. And that's why I think so many enterprises have started to use it already. So to give you an example and to give you a real live story of a large enterprise that's using Redshift, I want to introduce to you Greg Johnson, who's the head of analytics for Nokia. Please welcome Greg.
Hey, thanks, Andy. So I am Greg Johnson. I'm head of analytics for Nokia. I am in the mobile phones group. This is the group that ships feature and affordable smartphones. Last year, Nokia shipped over 350 million phones to globally. Most of our markets are emerging markets. For example, Asia Pacific, India, Africa, and South America. The group that I'm in is the Express Internet Services group. This group is designed to provide internet services to all the emerging markets. This is for the billion people that don't already have internet services available to them. We have a variety of services. The first one I want to talk about is the Express browser. The Express browser is a full HTML browser. It's a proxy-based browser. All these services run on a cloud-based service. Currently, we have in the cloud over 2,200 servers in 5 data centers globally. One of the data centers is actually AWS data center. Our users have viewed more than 60 billion minutes of HTML content last year, over 20 million website domains. And the primary advantage of having a proxy-based HTML browser is that we can compress the data and save users over $1 million a day over their data charges. The platform also includes web apps. So these are full web apps that use the browser as a platform. And Nokia's actually built purpose-built web apps. The one I have in the screenshot is Express Now. Express Now is a URL recommendation app, and it's designed to both showcase the APIs for the web apps as well as use the data that we collect from the rest of the services to build recommendations. Tying all the services together is the Business and Intelligence Analytics Platform. That's the group that I'm in. And there's a lot of talk in the press about big data. I actually hesitated to put that on my slide even, but we actually do generate big data. Currently from our all Express Internet Services, we're logging over 800 gigabytes a day of data, and we expect that to double by the end of the year. And I spent the last 2 years building up a traditional relational database and a BI platform. And towards the end of last year, our data volumes literally broke the database. We were no longer able to cost-effectively scale the database and do anything useful on it in terms of queries. So earlier this year, I started exploring using Redshift to replace our traditional relational database. And in the course of about 2 months, we're able to migrate most of the high data usage from the traditional relational database over to Redshift. Another big paradigm shift that we've been undergoing is getting away from using the traditional waterfall approach to build reports in the BI tools. We're moving to more of a hypothesis-based reporting where we can use big data BI tools to investigate the type of reports we want to do and do data mining, and then actually spend the time to develop the code to do those. So I mentioned the Express Now app. It's actually a Hadoop-based app, so we're using Hadoop for the recommendation engine, and that's also being hosted in Amazon Web Services as well. Just to give you some flavor for how we're using the data, we set up all these services are running in Amazon Web Services, and we want to try to create as much value from the analytics and BI tools that we can. On the first left-hand side is the machine learning. This is recommendations engine that I mentioned powering some of the apps that we're using. We're also starting to collect a lot of unstructured data for social media, and that's being primarily put into the Hadoop-based platform to do sentiment analysis type analysis. And additionally, we're doing a lot of statistical analysis on large data sets. These are tens of terabyte data sets. And we're using the statistical analysis to do forecasting and predictions, for example, to do churn forecasting and active user growth. And I mentioned as well, too, we are using the BI tools and starting to move into big data BI tools. One of the primary advantages that we've found using the Amazon Web Services, particularly for the database and Redshift, is we're seeing greater than 50% cost savings over traditional relational databases. And our queries are finishing at least 2 times faster than with our existing database. Another big advantage that we're seeing is because Amazon manages the database, we don't have to staff up for a DBA for a database administrator. Amazon takes a lot of the burden out of having to manage the database. So that's been a huge saving for us in terms of staff and probably more importantly, expertise. It's difficult to find people knowledgeable to manage databases for these large multi-terabyte size databases. We're also finding that in the Hadoop space, the BI tool platforms and the BI tools are fairly immature, and the space is rapidly changing. So we've been trialing and doing proof of concepts of some of the BI tools that are available in the AWS marketplace. So this has allowed us to very rapidly try new tools. In just a matter of days, we can fire up a new tool and see if it's going to provide some benefit, because there are a lot of them available as services. So we can quite rapidly try new tools, and if there's a new tool that's coming out, we can very easily try it. Another big advantage of AWS is all the services are on demand. So as I mentioned, our service is scaling very rapidly. We expect it to double by the end of the year. So we're utilizing the Amazon services to be able to scale up Redshift, to scale up S3, to be able to use EMR, the Elastic MapReduce on demand if we need more compute resources. And we're also using data pipeline to tie all the Amazon services together for workflows, as well as our own data services as well, too. So that's all I had today, so thanks for listening.
Thank you, Greg. So when we launched AWS back in 2006, developers were immediately excited. However, a lot of the pundits said, well, these are kind of interesting, these services, but they're just going to be toys for developers, not going to be used for anything real. And then as developers started building real applications and startups started using these, people said, well, okay, they may use them a little bit in their business, but they're not going to really be the basis of any business. And then as startups started using AWS to be their entire technology infrastructure platform, people said, well, fine, startups may use it, but enterprises aren't going to use this. They're not going to get comfortable with the cloud. And then as enterprises started using the cloud, they said, well, they may use them for minor things, but they're never going to run major workloads on top of the cloud. And as enterprises have now started to run mission-critical workloads and all kinds of workloads on top of the cloud, the question of if things are moving to the cloud is not really a question anymore. The only question really is how fast and which applications will move first. And what's interesting is that most of the biggest world events now are being brought to you via the cloud. You can look at the Super Bowl was streamed last year via AWS, so were the Olympics. Most of the big reality shows do their voting and run on top of AWS. If you look at the Mars Curiosity landing that NASA did last August, that entire landing was streamed and broadcasted on top of AWS to their website. And then if you look at the Obama campaign last year, first of all, the US presidential elections, most of the networks used AWS in some capacity on election day to handle the results and to display those results. But the Obama campaign, where their technology platform was largely credited with one of the differentiators in winning the election, was built completely on top of AWS. 200 unique applications. It's a pretty amazing architecture that they built. 7,000 concurrent call center users, 1 million calls on election day, 500,000 requests per second in their apps on election day. They were giving real-time data through mobile apps to their people on the ground on election day to tell them whose doors to knock on and who to call to get them to vote. Incredible. And they did all of this where they basically built the whole thing up in about a year, and they're going to take the whole thing down quickly because the election was over. And it really is true that things are possible today with the cloud that were never before possible. And to show you, apart from the examples I just gave, a real-life example of how this isn't a throwaway line, but is actually happening in practice, I want to introduce to you Ryan Tudhope, who's the co-founder of Atomic Fiction, who was doing something that people didn't really think was possible before, all on top of the cloud. Ryan.
Well, thank you so much, Andy, and thank you to everyone at Amazon and AWS for making this incredible conference possible. My name is Ryan Tudhope, and I'm one of the co-founders of Atomic Fiction, which is a visual effects and animation company that's based right here in the San Francisco Bay Area. Today, I want to tell you all a little bit about our company and what makes us tick, and how we're using AWS to completely change the game in our industry by rendering everything in the cloud. Our story actually goes way back. We love to make fun of ourselves in front of really large audiences. So this is my business partner, Kevin Bailey, and I, sometime in the mid-'80s, from what I can tell of this photo. And like a lot of kids growing up in the mid-'80s, we were surrounded by technology and computers, and we obviously loved using computers. But we also just really loved movies. And we couldn't get enough of them. We watched every movie we could. And we realized that the common thread between all of these films was visual effects. It was when the filmmakers were using visual effects to tell a story that couldn't otherwise be told any other way. And that's why we made it our dream to tell stories and to entertain people using a computer and using visual effects. And since that time, we've been incredibly fortunate. We've had an opportunity to work on dozens and dozens of films with amazing directors. We've also had an opportunity to work at some really amazing companies as well. Companies with 1,000 artists that are really big and have a huge pipeline, and you can get a ton of work done. And there's a great thing about that. And then there's a great thing about really small companies with just a few dozen people, where it's nimble and fast, and there's a great culture and vibe, and things are a lot more efficient. And so a few years ago, we had the opportunity to launch our own company, and so we started Atomic Fiction. And it was really a combination of these two philosophies, a big company infrastructure combined with a small company vibe and culture. AWS plays a big part in that big company infrastructure, and we just bring the vibe and culture. So this is a couple of pictures of our office, very open and collaborative. We love for artists to be able to communicate and yell right across the room and see what each other are doing and hear calls with our customers and really get a good sense of what's going on. We also love to dress up funny every once in a while. But I wanted to show you guys this picture just to show you how small we really are. We're only about 30 or 40 artists at any given time. But at the same time, this big pipeline and infrastructure that we've been able to create behind Atomic Fiction is what allows us to play with the big boys. And so we're cutting up our shots against films where companies 30 times our size are working, and we're having a great time and a great opportunity to do that. I thought I would play our show reel for you all. It's the best way to show you what we've been up to and a little bit of eye candy. And we usually use this to show prospective customers or artists that we may want to work with, and we'll go ahead and play that now. Thank you so much. So you might still be asking yourself, what does this all have to do with AWS? And it actually has a lot to do with it. When we were starting our company, we realized that it really wasn't about the technology, it was about the people, and that our artists and the people that we work with are the most important asset. And I think this is probably the case with all companies. And so we really wanted to invest in having an absolutely rock star team, and we wanted that team to be nimble and small, but we wanted them to be the best in the world. We also had to pair that with some really smart technology and look for ways to cut costs, because at the end of the day, visual effects is a very competitive industry, and we want to make sure that every dollar of our clients' money ends up on the screen looking really awesome. So the first thing we decided to do is that we weren't going to build this. It's amazing the extents people go to make that stuff look cool, and it does look cool, but at the same time, it's just a lot of expensive, hot hardware that's sitting there depreciating and that you have to replace every 3 years. And for us as a visual effects company, especially one that wanted to be small and nimble, we simply couldn't afford to do that. So what we decided to do is look for other ways, and that became AWS and the cloud. So I want to tell you a little bit about rendering also, in case you guys are unfamiliar with that. So rendering is really, for visual effects artists, like watching the paint dry. It's when the computers chug away at the scene file that you've been working on all day, and after a couple hours or all night, it spits out an image of what you've been working on. And we all get to talk about what that work is, and we get to critique each other and figure out what to do next. So it's really important that we have all that hardware there. And what we like to say with our AWS story is that we have a Pixar-sized render farm in 1 minute, and then we're right back down to the iMac on our decks the next. And that's really critical for us from a business standpoint, because we basically only pay for what we use, and we really treat rendering like a utility, just like gas or electricity. But there's also this side benefit, which is that you know, as an artist, you need to see stuff more quickly. You really need to get feedback fast, and you need to understand what you need to do to make the shots look better. And because you're paying by the proc hour, you can actually just put more machines on the job and get it done 10 times faster, and therefore you get more iterations throughout the day. So one of the projects that we had an amazing opportunity to work on this past year was Flight. And besides getting an opportunity to work with one of our filmmaking heroes, Flight was a truly groundbreaking film for the visual effects industry because it was the first major studio motion picture to be entirely rendered in the cloud. The other side benefit and what's really interesting about this project is that, you know, like you saw, we're a pretty small company. This film started out at around 130 shots when we were breaking down the script. And as we got into filming and we you know, got out into production and we started editing the movie, we realized that Mr. Zemeckis had increased the scope slightly to over 400 shots. And as a small company, we need to be able to move with the needs of our clients, of course. And without AWS behind us, without that horsepower, the seemingly unlimited horsepower that we have, that just wouldn't have been possible. Here's a typical chart of what it looks like rendering over the course of a project. You have, you know, these maybe some deadlines in the beginning. You have a temp screening or a trailer delivery. Throughout the middle of the project, you might have a couple of more milestones. But then you can see the render requirements get really big at the end of the project. And I promise it's not because we procrastinate. It's because there's this last 10% that goes into shots that's really hard to do, really hard to make something look real. It's really easy to get 90% of the way there, and then you just spend an immense amount of time in that last kiss of love is what we call it. And that takes a lot of computing power. And so if you look at some of the stats, we actually used over 1 million core hours in AWS to render Flight over a 6-month period, which is the course of the production schedule on that show. We scaled month over month in crazy ways. We used more and more horsepower. And what's most astounding to me is that we used almost half of all of the core hours in just the last 30 days alone. So it really shows you how important it is to us and to our clients that we have that ability to really scale up and use all the horsepower we need when we're trying to do that last 10% and make something look really perfect and real. So I wanted to break down a shot with you all, just so you can kind of see what goes into it. What are the types of things that we actually are rendering in the cloud? This is one of the final shots from Flight as the aircraft is starting to tear itself apart, of course, in a nosedive. And every shot starts out pretty simple. It starts out as a pretty simple animation pass. This was done by one of our talented animators, where we really are just trying to block out the shot, figure out where the camera is, working with Mr. Zemeckis on you know, what it's going to look like as it's cut into the rest of his film. And then we might, early in the phase, render it out. So we put it up in the cloud and render this out so we can see what it might look like, a little more polished, a little more finished. And we actually shot a bunch of the footage that you see back there with all the clouds on a helicopter rig. But just as an example of how even a single shot can increase in scope, we realized that at this point in the story, it felt like the airplane wasn't enough of a nosedive. It just didn't look scary enough. So we opted to completely create the background digitally. So using satellite images and some of the photos we had taken, we created this background. Using Photoshop, we're able to create some map-painted cloud elements. And then another element that needs to be rendered by someone is all these effects elements of foreground smoke that fly by the camera, just to give a sense of speed and make the shot more dynamic. And then the actual airplane itself is a really big render. I mean, this might take a few hours per frame or more, just because of all the reflections and the high detailed textures, and it just takes an immense amount of memory. So we really use some of the biggest instances that Amazon can throw at it for this. And then this kiss of love that I was talking about is just a little bit of contrails, just a little bit of energy to kind of make the shot a little more interesting. Plus you always see this when you're flying and it looks cool, so we decided to throw it in there. And you layer it all up in a final composite, which again gets sent up into the cloud. And what's interesting is that because we're already rendering in the cloud, all of those elements are sitting up there waiting for us. So when the artist kicks off their final composite, it all comes together, and that's how the final shot looks. So that's it for me. I really, really appreciate your time, and thank you all. Hope you have a wonderful week here.
That was very cool. So I'm going to close this talk by answering a question that we get asked a lot, and that I expect will get asked even more as more and more technology companies are rushing to build something very similar to what we have built over the last 7 years. And that question is, how do I think about who to choose as a cloud partner? There's going to be lots of noise. And so we thought we would tell you the things we think are most important as you evaluate this over time. The first thing I would tell you is that when we launched this business 7 years ago and conceived of it 10 years ago, one of the reasons we did so was that we had to get really good running deep infrastructure services deep in the stack and reliable, scalable, cost-effective data centers just to grow Amazon.com, the retailer, the first 10 years of Amazon. And I can tell you that after 7 years of being in the market with hundreds of thousands of customers in over 190 countries, with every imaginable use case, where they use us to any degree without any warning, we are much better at this today than we were 7 years ago, and we thought we were pretty good 7 years ago. There's an expression we use sometimes internally, which is that there's no compression algorithm for experience. And you can't really understand some of the things you need to adjust and change and build for until you hit certain elbows of the demand curve running these types of services at the scale that we do. So we have a lot of experience doing this, and it's not easy to accumulate those learnings until you've actually had to go through those peaks. The second thing I'd tell you is that you're going to want to work with a cloud provider that has the broadest possible functionality, the most number of services, the most number of features within those services, because it allows you to do so much more with the workloads that you want to actually build from scratch or move to the cloud. And so what you don't want to have to settle for is an AWS circa 2009 type of platform, as a lot of other companies are just launching their solutions. We have much broader functionality than anybody else, and we are iterating and innovating at a very fast clip. You know, it's motherhood and apple pie to say you're going to listen to your customers and then deliver quickly on their behalf. Everybody says it. But if you look in practice at the difference in delivery pace and innovation between AWS and almost any other technology company in the last 7 years, there's a pretty stark contrast. We are delivering at a much faster clip. So you get a lot broader functionality, and you're getting innovation and additional capabilities at a faster pace than anybody else is providing. The fourth thing is that you're going to want to work with a provider who's got a broad global footprint. That's going to matter. You have global end users, and you'd like to provide a better customer experience and lower latency by being able to serve them more locally to where they are. Today, AWS has 9 regions throughout the world, and we're not done growing geographically. The fifth thing I'd tell you that matters is the pricing philosophy of whoever you're working with. You know, almost every company I know of cares about costs and cares about prices. There are some who at any one juncture, for whatever is going on in their business cycle, may not care as much about costs, but eventually they will care about costs. Business changes, circumstances change. Everybody's going to care about what your cost structure is. You want to be working with a partner who has a pricing philosophy that they're going to keep lowering prices for you in a metronomic way. At Amazon, in every business Amazon's in, especially AWS, we run high volume, low margin businesses. We love those types of businesses. We're very comfortable operating those businesses. It's in our DNA. It takes, by the way, a unique set of operating skills to be good at running high volume, low margin businesses. You can't flip a switch overnight and be good at those, because the scale and the logistics of that are very different from running high margin, lower volume businesses. Amazon knows how to run these types of businesses. AWS consistently is working to lower your costs, and that, I think, is going to be important for you both now and in the future as you decide who to build on top of long term. And then the last thing I would tell you to think hard about is the ecosystem. And when you're making a technology change as substantial as this one, having partners who can help you move to the cloud in the best possible way, being able to run all the software you're used to being able to run on top of a particular platform, that partner ecosystem is a huge accelerant and makes your life much easier. And the customer ecosystem, being able to know that lots of companies in your segment or lots of companies geographically close to you, lots of your friends are using a particular platform is also very useful as you figure out how to best optimize that platform over the long term. AWS's ecosystem, as I talked about earlier, is really vibrant and growing really fast and already is helping so many companies move to the cloud in a safe and successful manner. So with that, I'm going to thank you for coming. I'm going to thank you for listening to the talk, and I hope you enjoy the rest of the breakout sessions today and feel like it's worthwhile. Thanks again.